Okay. So, where did we leave off yesterday? We learned the 6 trig functions, the difference between the inverses. We started answering some questions. Great. Is this where we left off? Okay. So we left off yesterday with the 3, 4, 5 right triangle. You told me, and then I gave you the angle theta is the one adjacent to the 3 and the 5, opposite the 4. 5 is hypotenuse. So the sine of theta is 4/5, the tangent of theta is 4/3, the secant of theta is 5/3. The sine, opposite over hypotenuse, tangent, opposite over adjacent, secant, hypotenuse over adjacent, right? And then I said, what should we call this other angle? And if this angle theta, this one's 90, then because the angle sum of all the angles in the triangle is 180, that third angle we could call 90 minus theta. Agreed? Okay. So now tell me, what is cosine of the angle 90 degrees minus theta? And it is 4/5, because the adjacent is 4, the hypotenuse is 5. Great. What is the cotangent of 90 minus theta? Cotangent is what over what? It's adjacent over opposite, so it's going to be 4/3. And what is the cosecant of 90 degrees minus theta? So hypotenuse over opposite, 5/3. So yesterday we did sine of theta is 4/5, tangent of theta is 4/3, secant of theta is 5/3. Today we see that the cosine of 90 minus theta is 4/5, the cotangent of 90 minus theta is 4/3, the cosecant of 90 minus theta is 5/3. You notice anything about these two sets of trig evaluations we just did? Sine of theta and the cosine of 90 minus theta, output is the same thing, 4/5. Tangent theta and the cotangent of 90 minus theta, output is the same thing. The secant of 5/3 and the cosecant of 90 minus theta, also 5/3, same thing. Think that's a coincidence that these functions are outputting the same thing? No. In fact, that is kind of the definition of co-functions. Sine and cosine are co-functions. If you input complementary angles into them, because isn't that what that is, a complementary angle, you'll get the same outputs. Tangent and cotangent are co-functions. If you plug in complementary angles, you'll get the same output. Secant and cosecant are co-functions. If you input complementary angles, you get the same output. That's going to be an important rule we learn even more detail about later on, because when we start graphing these functions, this means if I take the graph of cosine and I reflect it in the y-axis and shift it to the right 90, I'll get the same graph as sine. So they're the same exact shape, just a reflection and a shift of each other. If I take the graph of cotangent and I reflect it in the y-axis and shift it to the right 90, I get the graph of tangent. If I take the graph of cosecant, reflect it in the y-axis, shift it right 90, I get the graph of secant. Okay? So they're very much similar functions, these co-functions. Not only that, they're reciprocals of each other. What's the cosecant of theta? 5/4. What's the cotangent of theta? 3/4. What's the cosine of theta? 3/5. Okay, there's a lot about that. Feel pretty good about just general SOHCAHTOA and SHOHCAHTOA? Yes, good. Now let's start talking unit circles. So let's graph a set of axes. Let's put a circle on it. Okay, we're going to call this our unit circle. And the reason it's called a unit circle is because it is a circle of radius what? How many? One. Okay, A unit circle is a circle of radius 1. And this is your x-axis, this is your y-axis. There she is. She wasn't skipping. I told you. You should have heard it. 2. This is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. Okay, so that's your unit circle. So let's graph an angle in this unit circle. Give me an angle. What's your favorite angle? 14. I heard 37. I actually didn't. I just didn't like all the angles you guys picked. So here's an angle of 37 degrees. Okay? The reason the unit circle is so valuable is because finding where that terminal side touches the circle, the actual coordinates of these points, we'll call that point XY, very valuable. Okay? The unit circle is our way of taking all this geometry, these triangles, this trig, and connecting it to algebra, coordinate system. Okay? Points. So what can you tell me about this angle? Well, if I were to draw a right triangle inside this unit circle like this, what can you tell me about any of the lengths of the sides of that triangle? The hypotenuse is 1. How do you know the hypotenuse is 1? The radius of the circle is 1. So therefore, the hypotenuse of that right triangle, that green right triangle, is 1. What else can you tell me about any of the lengths of the sides? What's the length of the base? Less than 1, yeah. I want you to be more specific, but still not a number. X! Isn't the length of that side going to be X? Isn't the X coordinate of that point going to be the length of the base of that triangle? And then what can I label the other length, the other leg of this triangle? It's going to be Y. So let me ask you this. In the unit circle, it has to be a unit circle. None of this makes sense if the radius is not 1. Radius has to be 1. So that, the hypotenuse is 1. According to this triangle we have drawn here, what is the cosine of 37 degrees? Cosine is adjacent over hypotenuse. So what is that? X over 1. Well, what's anything divided by 1? So it turns out the x, which by the way, x is the x-coordinate of this point, is the cosine of the angle 37 degrees. That connection is the most important thing to understand. Why don't you practice rolling your pencil at home? You're too terrible at it. That's my funny way of telling you, stop it, you're driving me nuts. Okay. Let's keep hearing. Great. That's awesome. Thank you. All right. So the x-coordinate of this point. Anytime you draw an angle, that's the most important thing to understand right now. Any angle you draw in the unit circle, whatever the x-coordinate of that point is going to be the cosine of that angle. Make sense? And then how can you verify that? Because you can actually draw a right triangle where the adjacent side is x, the opposite side is y, the hypotenuse is 1, and it just kind of makes sense. So what is y? Well, what's the sine of 37 degrees according to this picture? Y over 1. So therefore, y is whatever the sine of 37 degrees is. Okay? So what does this mean? Let's use GeoGebra and investigate this a little bit further. I want to draw a circle of radius 1, so I got to zoom in a bunch. Okay. I'm going to plot the point 0, 0. That'll be the center of my circle. Plot the point 1, 0. And then let's put a circle. There's our unit circle. Agreed?
Cool. Let's, I'm going to put a point on the unit circle, and then I'm going to draw a ray emanating from the point A and going through that point. So now that point will be stuck on the unit circle. All right, and that ray is going to represent my angle, so let's label that angle. That's the angle BAC. So what you're looking at right there is an angle of 56.37 degrees. Let's show some more decimals. Let's say around 5 decimal places. 56.37272 degrees. And as I move that, you can see the angle adjusts, right? 167.59588. That's great. Now I also want to show the coordinates of this point. So let's change this to a value instead of the name. Okay. So let's find an angle in here. How about that one right there? 47.1784 degrees. Let's get the calculator out, and just for fun, figure out what is the cosine. Now make sure you're in degrees mode, which I am not. Okay, so now I'm in degrees mode. I'm going to type the cosine of 47.1784. And that's going to be degrees, not radians. I hit enter, and I get 0.67971785565, or 8656. Well, look at the x-coordinate of this point, 0.67972. Pretty cool? Let's do the sine of that angle. What is the sine of 47.1784 degrees? 0.733473669. What is the y-coordinate at this point? 0.73347. Okay? So I think it's pretty well established that whatever that this x-coordinate is the cosine of that angle, this y-coordinate is the sine of that angle. Okay? That is the biggest, most important concept of the unit circle. It's the coordinates, the values of the coordinates are the cosine comma sine of the angle that those points correspond to. So that way, if you ask me what's the cosine of 30 degrees, I don't actually draw a triangle. I look for coordinates of a point. You say, what's the cosine of 30 degrees? I look for a point whose x-coordinate is right up at 3/2. What's the sine of 30 degrees? I find a point whose y-coordinate is 1/2. And that's how we use the unit circle to answer this question. Now, so do you believe me now? Do you believe me now that this x-coordinate is the cosine of that angle and the y-coordinate is the sine of that angle? This new definition of sine and cosine is better than SOHCAHTOA. Because SOHCAHTOA is right triangle trigonometry. Can you have a right triangle with an angle of 120 degrees? No. So SOHCAHTOA fails pretty quickly. It only works for angles between 0 and 90. This new definition of sine and cosine, sine being the x-coordinate of a point on the unit circle, y-coordinate, cosine being the x-coordinate, it'll work for any angle at all. All I got to do is take this point, move it over here. There's 149 degrees. What's the cosine of 149.36357? Negative 0.86042. If you don't believe me, check in your calculator. What is the cosine of 149.36357? Negative 0.86042. You can't draw a triangle to figure that out. You can't make a right triangle that has an angle of 149 degrees. Okay? So the x-coordinate is the cosine of that angle, the y-coordinate is the sine, and that is only true if it is a unit circle, radius 1. Pretty cool stuff, right? Okay, so now what we got to do is memorize this for like 17 different angles. That's great. All before Friday. Yay! Okay. Here's the book's little summary thing. Because, here, let's go back up here. What is the tangent of 37 degrees according to this triangle right here? What's opposite over adjacent? Y over x. So if I want to know, let's go back to GeoGebra. What is the tangent of 149.36357?
I have to take this number and divide them. So what's a positive number divided by negative? It's going to be a negative something, right? Definitely going to be a negative something. Okay? What if I wanted to know the cosecant of 149.36357 degrees? I take which of these coordinates? First or second? Cosecant is the reciprocal of what? Sine. So I take this decimal right here, 0.50959, and I take the reciprocal of it. In my calculator, I type 1 divided by that, and you'll get 2 point something. Does that make sense? Okay? So all the unit circle shows us is sine and cosine, but that's all you need to know. If you know sine and cosine, you know all the other 4 trig functions as well. Because tangent is actually sine divided by cosine. Cotangent is cosine divided by sine. Secant is the reciprocal of cosine and so on. So here's your textbook summarizing all of this. Basically one little blue box to summarize the entirety of the unit circle. Now, I always use the Greek letter theta. Your book likes to use the letter t. So t is actually your angle. xy is the point on the unit circle, radius 1, that corresponds to that angle. So this is the point, and this is the angle, and they correspond to each other. If I increase the angle, the point moves. Sine of the angle is the y-coordinate. Cosine of the angle is the x-coordinate. Tangent of the angle is y divided by x. I would write theta in your notes, to be honest with you. Cosecant of the angle is the reciprocal of the y-coordinate. Secant of the angle is the reciprocal of the x-coordinate. Cotangent of the angle is the reciprocal of tangent, which actually turns out to be the x divided by the y. Wait, just need this back. Okay? We're good to go? Now, we are going to memorize, all multiples of 30, all multiples of 45. And you're going to memorize the coordinates of the points. Okay? So, for example, draw a nice XY axis. Put a nice circle centered on that. Okay, this is a radius 1, x-axis, y-axis. And let's start with, let's say 30 degrees. So 30 degrees is going to be an angle that looks about something like that. So that's 30 degrees. So what I want to know is, what is the x-coordinate of this point? What is the y-coordinate of this point? Do you have any way, what is the x-coordinate of that point going to be? What did we just learn that x-coordinate is? Do you have any way right now of knowing what the cosine of 30 is? Without a calculator. You didn't come and have a calculator Friday. Do you have any way of knowing what the cosine of 30 degrees is right now? And I don't want it as a decimal. I want it in exact fraction radical form. Slider can't even help you with that. You actually do. You learn it in geometry. In geometry, you learned a little something, something we like to call the 30, 60, 90 triangle. Right?
The short side on the 30, 60, 90 triangle you probably called 1. You called the hypotenuse 2. And you called the adjacent side, according to the Pythagorean theorem, radical 3. Right? 4 minus 1, 3, square root. If you know that, you already know the sine, cosine, tangent, secant, cosecant, cotangent of not only 30 degrees, but also of what? 60 degrees. And you probably also learned another triangle that was what? 45, 45, 90. That's all you need to know. If you already know those triangles, you actually know the unit circles. You just got to know how to build it now. Okay? So, I know that the x-coordinate of this point is whatever the cosine of 30 is. I am going to then use this triangle to figure out what cosine 30 is. So according to this triangle, what is the cosine of 30? The square root of 3 over 2. So on the unit circle, radius 1, the x-coordinate of the point that corresponds to 30 degrees is radical 3 over 2. What is sine of 30 degrees? 1/2. That's it. There's the first, technically it's the second of the most important angle in the unit circle. Boom, 30 degrees. You have to write down how many radians that is as well. We'll get there. But that's it. Now, how in the world do I figure out what the cosine of 150 degrees is? That is the question. Well, let me draw 150 degrees. It's going to look a little something like this. It's this angle right here, 150 degrees. If I can figure out what the x-coordinate of this point is, then I now have my answer of what cosine 150 degrees is. Negative radical 3 over 2. That is awesome. Cosine of 150 degrees is negative radical 3 over 2. How did you know that? It's the x-coordinate of this point. Isn't this point a perfect mirror of this point? And if it's reflected over the y-axis, isn't it going to have the same x and y coordinate except the x is opposite? What is the sine of 150 degrees? Positive 1/2. It's going to be the same as 30. Okay? So by knowing cosine of 150 is whatever the x-coordinate of that point is, I can just use some of the most basic concepts of geometry, symmetry, to figure out what that coordinate is. I don't have to draw a right triangle that has an angle of 150 in it, because that's impossible anyway. Right? So that's how that works. Now, what we do a lot of times, actually, is we still go ahead and draw a triangle. But what is the actual angle of that triangle? 30. We actually call that a reference angle. Do I have any way of knowing what the cosine of 150 is if I don't know the cosine of 30? No. In order to figure out what cosine 150 is, you have to know what the cosine of 30 is. So that angle, 30 degrees, is our reference angle. It is the angle we refer to. Now, is cosine 30 the same thing as cosine 150? No. They weren't. In fact, they're opposites of each other. Don't just answer for the sake of answering. I know it makes you laugh, but I don't care. Okay, 30 degrees is the reference angle. That is the actual angle I know. And then I use my knowledge of symmetry and reflection to actually figure out what that x-coordinate is. So lots of times you will still draw a triangle. It's a right triangle, so it won't actually have 150 in it, but it is the angle you refer to get your answer. Okay? Give me another one that's a multiple of 30. See if we can't figure it out. 90. I like 90. 90 is a good one. What are the coordinates of this point? 0, 1. Every single person has said 1, 0 today. Every single time.
So what is the cosine of 90 degrees? 0. What is the sine of 90 degrees? 1. What is the tangent of 90 degrees? You have to take the y-coordinate divided by the x-coordinate. What's 1 divided by 0? It's undefined. Tangent of 90 is undefined. Interesting. Okay? Can I draw a triangle to represent that? That would be a triangle that looks like 90 degrees here, 90 degrees here, 0 degrees here, hypotenuse 1, length 1 here, and length 0 here. Yeah, that's great. Absolutely. Sine of 90 is opposite over hypotenuse 1. Cosine adjacent over hypotenuse 0. Tangent opposite over adjacent, undefined. It's not a realistic triangle. But you can use it to answer questions, actually. What's that? Yeah, like for the rest of your life, you just go through that. Yeah, absolutely. We've zoomed in an infinite number of times. That's what it looks like. Okay? So how about, when I said another multiple of 30, what I meant was like something like 210. So here's the angle 210. This angle right here. What is the cosine of 210 degrees? How do you know you're still referring to 30? What is this angle right here, this terminal side makes with the x-axis? 30. What's 210 minus 180? Your reference angle is still 30 degrees. So therefore, I go to this point and say, well, hey, cosine 30 is radical 3 over 2. Mine must be negative radical 3 over 2. What is the sine of 210 degrees? Again, I go to my reference angle. Because this angle right here is 30, well, the sine of 30 is 1/2. Mine has to be the opposite of it because my terminal side is in which quadrant? 3. So the cosine of 210 is negative radical 3 over 2. The sine of 210 is negative 1/2. So we always go back to our reference angle, which should be 30, 60, or 45. Okay? Always. Feel pretty good about how this works, that we can actually start filling the unit circle out now? I got a nice blank unit circle for you. Just to give you a heads up as to what Friday's quiz looks like, you'll get one of these, and you get 1 minute to fill it out. No. We used to have a teacher who would get you your own paper, blank paper. So you had to spend time drawing the axis, drawing the circle. And as time went on, the number of points you could get started going down. So if you could do it within the first minute, you got full credit. But as time went on, went down to like 95, 90%, 85, 80. That's stressful, right? I don't do it like that. Here's what I'll do. I'll give you a blank unit circle like this, exactly like this. And from memory, no notes, no calculator, no nothing, you fill it out. Then when you're done, you turn it in. I will then give you one that's already filled out and is correct. You will then take the second part of the quiz, which is answering questions like, what's the cosine of 150 degrees? And you can use your unit circle to answer this question. So that way, when you go to answer questions about the unit circle, you've got a correct one to use. I don't want you to miss problems on the quiz because your unit circle was wrong to begin with. You miss a point for the wrong unit circle and then miss all the points that you used that angle. That's not fair. So that way, maybe you miss an angle on your unit circle and you miss a minimal number of points for it. Then you still take the rest of the quiz. It's kind of fair, right? And basically, I'll time myself and see how long it takes me to do it. Both the filling out of the unit circle and the quiz, and you'll get that much time. So some of you might spend most of the time filling out the unit circle. I wouldn't advise it. So say you can take 20 minutes or however long the quiz is. Use the time. It's still kind of stressful, right? But it's fair. It's a fair way to do it. Now, eventually, I'll be asking you, like, what's the secant of 180 degrees, and you will not have a physical unit circle to look at. It will have to be completely from memory.
No calculator, no nothing. Okay, so let's start filling this thing out. What is the first angle that is worthy of being memorized? 0. So let's go ahead and label 0 degrees right here. Why do you think they gave 2 different labels for this angle? Because it's not only 0, we can also call that 360. Okay? That's basically, so we go around the circle once, labeling everything, and then once we start to repeat ourselves, we stop. How many radians is 0 degrees? 0 radians. How many radians is 360 degrees? 2 pi. Very good. What are the coordinates of that point? That's the point 1, 0. There you go. That's 12 questions already. Technically, that's like 24 different problems I could put on a quiz. What's the sine of 0 degrees? What's the cosine of 0 degrees? What's the tangent of 0 degrees? What's the secant of 0 degrees? What's the cosecant of 0 degrees? What's the cotangent of 0 degrees? What's the sine of 0 radians? What's the cosine of 0 radians? What's the tangent of 0 radians? What's the secant of 2 pi radians? What's the cosecant of 360 degrees? That's like 24 different questions I could ask you already, right now. Let's answer a couple. What is the cosine of 0 degrees? Cosine of 0 degrees is 1. Cosine is your x-coordinate. What is the tangent of 360 degrees? 0 divided by 1 is 0. Is 0. What is the sine of 2 pi radians? 0. What is the secant of 0 radians? So that's your cosine. What's the reciprocal of 1? Still 1. Secant is 1. What is the cosecant of 0 degrees? What's the reciprocal of 0? Undefined. So of those 6 functions, 2 of them have vertical asymptotes right at the y-axis. Secant and cotangent. All right, what's the next angle worthy of being memorized? 30 degrees. How many radians is that? Pi over 6. Very nice. Okay, so what are the x and y coordinates? In order to figure the x and y coordinates out, I would definitely refer to your 30, 60, 90 triangle. The x-coordinate is the cosine of 30. So according to your 30, 60, 90 triangle, what is the cosine of 30 degrees? Radical 3 over 2. What is the sine of 30 degrees? One half. What is the next angle worthy of being memorized? 45. How many radians is 45 degrees? Pi fourths radians. Okay, right around the number 0.75, a little bit larger than 0.75. I would highly recommend you refer to your 9th grade days of the 45, 45, 90 triangle, which you probably drew like that. 1 and 1 for the legs, radical 2 for the hypotenuses. What is the cosine of 45 degrees? 1 over radical 2. If on Friday's quiz I ask you, what is the cosine of 45 degrees, and you write 1 over radical 2, will you get full credit? Absolutely. You will. That was good. A lot of people said yes. You're learning. You're learning. You will. I'll give you full credit. I do not care about radicals in the bottom of a fraction.
AP doesn't care. IB doesn't care. They do not care. You will never miss points on an AP or IB exam because you did not rationalize the denominator.
Why do you spend so much time out of this?
Because your algebra 2 teacher was probably old. She's older than I am. Barely, no. Before the onset of technology, it mattered. Because how would an old Greek dude,
That's like, I don't know, they seem to be old, dead free dude.
how would they have found what 1 divided by radical 2 was as a decimal, approximately? Because they actually had methods for figuring out what the square root of 2 was as a decimal. And they had something called long division for dividing. But when you do long division,
when you do 1 divided by a decimal that never stops, how in the world do you do long division where what you're dividing by is an infinite decimal? You can't. So instead, they would have to have rationalized the denominator. So now they have their infinite decimal in here and a nice number there. And they could continue that long division until they got as many decimals as they needed. Much more accurate way of approximating a decimal. Well, nowadays we have technology, and we can just say 1 divided by radical 2, and it's just as accurate, so it doesn't matter anymore. Does that make sense? But,
I would not write 1 over radical 2 here in your unit circle. I wouldn't. Radical 2 over 2, if you write it as radical 2 over 2, you're going to notice patterns so much easier. It's nice having every single fraction we write have what as the denominator? 2 having the same denominator. So I would actually write in the unit circle
radical 2 over 2. Instead of 1 over radical 2, though I'd give you full credit for either.
Most importantly, I think it's very, very important you acknowledge that these are the same thing. Just memorize it. Radical 2 over 2 and 1 over radical 2 are the same thing. Because if I want to know what's the secant of 45 degrees? Well, now all of a sudden the reciprocal is going to have a radical in the bottom. That's not nice. So which one of these is better to take the reciprocal of? The first one. What's the secant of 45 degrees? It's just radical 2. That's so much nicer than 2 over radical 2. So knowing both of these is highly recommended. But in the actual unit circle, I would write radical 2 over 2. Because there's this really nice pattern. And it makes it easier to memorize. And it's easier to know which one's bigger. What's bigger? What's a bigger fraction? Radical 3 over 2, radical 2 over 2, or 1 over 2? What's the bigger number, 3, 2, or 1? 3. Radical 3 over 2 is the biggest of those. Radical 2 over 2 is in the middle, and radical 1 over 2, also known as 1 over 2, is the smallest. Yeah, if you really want to, you can call it radical 1 over 2, that they look even more alike.
Right? Okay, what's the next angle worth memorizing? 60. How many radians is that? Pi thirds. Again, we could use the 30, 60, 90 triangle. What is the x-coordinate of this point? 1/2. What is the y-coordinate? Radical 3 over 2.
Hey, I got a question. Whenever you take a point and you reflect it through this nice 45-degree line, what do you do with the coordinates? You flip them. So is it any surprise that this point and this point are just the flip of each other? No, they are perfectly symmetrical through the line y equals x. And then we already know this. How many degrees is that angle?
90. How many radians is that? Pi halves. And what are the coordinates of that point? 0, 1.
So here's the pattern. Radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. What is the square root of 4 divided by 2? 1. And then this just does the opposite. Radical 4 over 2, radical 3 over 2, radical 2 over 2, radical 1 over 2, radical 0 over 2. It's totally just a pattern. The square root of something over 2. The y-coordinates are increasing. As you turn counterclockwise, the x-coordinates are decreasing. Really not that hard to memorize. There's also some pattern using like your fingers, like, I can't remember. It's all on the YouTube video ones. There's all kinds of, people are already coming in. Molly McNamara is so excited to show me this YouTube video today that she found teaching me in a circle. She's like, it makes so much sense now. And then I taught today. No, there's some great YouTube videos out there. Like this trick about how to use the fingers. That's pretty cool. So if you're having trouble memorizing this, look on YouTube. It's great stuff.
How much time we got? Okay, we're going to call it a day. Your homework tonight is to fill in the rest of it.
You should be able to figure out the rest. For example, 120, 135, 150, 180, 210, 225. So fill in the rest. Make sure you get the radian measures for them. Yes, because aren't the rest of the coordinates just going to be repeats of these with negatives? Right? So you should, the first quadrant is all you really need to know. The rest is just symmetry. And then you also have the homework I gave you last night. Keep working through that if you didn't write it down yesterday. Here it is again. Enjoy.